My name is Rabiatul Adawiyah binti Ahmad Roslain. Today I will present about introduction our group project. Static is a branch of mechanics that studies force acting on object at rest or moving with the constant velocity. It focuses on ensuring equilibrium where no net force or moment exists. Core principles like Newton's law of motion guide this study, particularly the first and the third law. Static is crucial for designing safe and stable structure such as building and bridges, and for optimizing design by selecting the most efficient materials and geometries. Essentially, static play a vital role in ensuring the safety and reliability of various structures and systems in our daily life.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Zulaika binti Zulkarnain. My matrix number is CD240302. We have decided to examine the structural mechanics problem in this study for figure 2.1 because it involves to figure out how much the moment is created when a force acts on a system of bent columns. In this question, we have to determine the size and the direction of the moment around the point A that brought by a 600 Newton force at point C at a 50-degree angle. This selected topic provides us to find the moment and forces by offering a hands-on applications of theoretical ideas in structural engineering and solid mechanics. As we know, the moment of force is a moment equal to R times force, which is the R is a position vector while the F is the applied force. In particular, moments are subjected to the third law of Newton's motion law to maintain equilibrium. It is sum of F equal to 0 and sum of moment equal to 0. It is much easier if we draw an FPD to divide the parts by the vector decomposition. Also, the cross product in moment calculation, we can provide the right hand rule for ensure the directionality of the forces and moment. The moment's magnitude is moment equal to R times F times sine theta. So this is the questions that we need to solve and find the forces and moments.
Problem statement. This project focuses on kinematic analysis of rigid body to understand and verify the static equilibrium state under external load. It involves orienting axis, labeling force, applying equilibrium equation, and relating spring force to deformation. Negative value indicate the opposite direction of the force, as it always have a positive value. The project aims to understand and verify the static equilibrium state of rigid body under external load. Next, I will present objective our group project. First, examine an engineering problem and using the information from this course to provide appropriate solution. Second, to demonstrate the group's understand of the concept of the force vector, including its definition and practical application, and to develop problem-solving skill by solving relevant example related to moments. Third, to prepare a technical report focusing on force vector analysis of case study.
Assalamualaikum, my name is Hishamuddin bin Jamil. My number metric is CD240014. Today I'm going to present about mathematical modeling. Physical components: load, the object being lifted characterized by its weight or mass; cable, the lifting mechanism characterized by its material properties such as elasticity, tensile strength, and geometry, which is length and diameter. Forces and equilibrium: tension, the force exerted along the cable due to the load; gravity, the force acting on the load and the cable due to the Earth's gravitational pull; support reactions, the forces at the points where the cable is anchored or supported. Modeling considerations: static equilibrium, the sum of forces and moments should be zero when the load is stationary dynamic analysis. If the load is moving, consider the acceleration and resulting forces. While about material strength, assess the strain on the cable material to prevent failure.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Khairul Nisa binti Syarudin. Nombor kad matrik CD240077. I will present about result analysis and discussion. So, the problem is determine the magnitude and direction of the moment about point A produced by the 600 Newton force applied at C. First, we must find force. The force is 600 cos 50 degree and 600 sin 50 degree. The AB is 6 meter and the BC is 2 meter. The angle was given is 120 degree. So, the solution first, force equal to 600 cos 50 degree I plus 600 sin 50 degree J plus 0K. So, the answer is 385.67 I plus 459.63 J plus 0K. The RAB was given is 6 meter. That is for J only. Next, the point of RBC is 2 cos 120 degree I plus 2 sin 120 degree J plus 0K. So the answer is negative 1I plus 1.732 J plus 0K. Next, to find the point of RAC is we must combine point of RBC plus RAB. RAC is negative 1I plus 6 plus 1.732 J plus 0K. So we got the answer of RAC is negative 1I plus 7.732 plus 0K. To find the moment about point A, we use the formula of RAC multiply F. So, we can use the metric formula 3 multiply 3. For I, 7.732 multiply 0 minus of 459.63 multiply 0. So we got the answer of I is 0. Next, point of J. Negative 1 multiply 0 minus of 385.67 multiply 0. So we got the answer of J is 0. Then we find the point of K. Negative 1 multiply 459.63 minus of 385.67 multiply 7.732. And we got the answer of K is negative 3441.63 Newton. Next, I want to present about discussion of the result. So, to calculate the magnitude and direction of the moment about point A due to the 600 Newton force applied at C. Firstly, we must decompose the 600 Newton force into components. The force vector at C forms an angle 50 degree with the horizontal Fx and Fy. Second, we must determine the position vector R from A to C. using vertical distance and horizontal distance with the point at B is 120 degree. So we can calculate the position vector R. Next, we must compute the moment about A, and then calculate the magnitude and direction. So the magnitude of the moment is, we got negative 3441.63 Newton, and the direction is clockwise about A because the moment is negative.
In conclusion, the moment about point A due to the 600 Newton force applied at point C has a magnitude of 3441.63 Newton may act in the clockwise direction. This result is obtained by decomposing the force into its components, determining the position vector from A to C, and calculating the cross product of the position vector and force vector. The negative sign of the calculated moment indicates that it rotates in clockwise direction about point A. This analysis demonstrates how to combine force component and geometry to evaluate the rotation effect of force.